Dear participants, welcome you all to the final session of the 5-day FDP series. Today's session is going to be addressed by Dr. Ravi Kumar V, Professor and Head, Department of Computer Science and Engineering, VVCE, Mysuru. He has rich experience in teaching for over 2 decades. He has many research publications in international journals and conferences and an AICT conference funding to his credit. He has been invited as member for Board of Examination and Studies in many institutions and as editor in peer-reviewed journals. On behalf of CS department, I extend him a warm welcome to the session. A hearty welcome to all the online participants and wish you a fruitful session. On this occasion, I take this opportunity to express my sincere gratitude to all of you for encouraging and supporting us in all our endeavors. Dear participants, I appeal you to render your valuable feedback after the final session. The feedback link will be sent to you via registered mail. Thank you all once again. And now it is over to Ravi Kumar to continue with the session.
Thank you, Dr. Parmesh, for introducing. Dear participants, I welcome all of you to this, you can say that FTP or a webinar on the topic Insight into Machine Learning, NLP and Research Challenges. Basically, I've divided this presentation into 3 parts. One is I'll be just briefing about what is machine learning, and I'll be talking about introduction to NLP also. And then at the end, I'll be giving some research challenges. I'll just giving some of the statements which is you can take up as a research work. And as I said, I'll be giving only the statements. You need to explore it. I hope this is the last session of this FTP. You have come across 4 eminent speakers, starting from Dr. Ashok Rao, Dr. Raghuveer, Dr. Anil Kumar, and Dr. Mahananda. So they're all well-wishers of our institution, and they have given lots of input towards the research. I hope everybody has spoken about the similar kind of things in their speech also, or in their delivery. I hope yesterday I was looking at the Dr. Mahananda's presentation. He was also pointing out about AI application with respect to the medicine or the medical domain. He was also talking about how important the NLP in terms of AI also. So what I thought, since the audience are both faculty as well as research scholars, there are a few students are also there. I thought let me brief about machine learning and NLP. And in between, I'll be taking one simple demo how to use the Stanford parser or the parts of speech tagger. And at the end, if the time permits, we'll also look into how we can use the available libraries of Python for NLP. Now, let me welcome all the participants for this webinar. So once again, I welcome all of you to this webinar. I thank Dr. Parmesha for introducing me. So my presentation, the outline of my presentation is as follows. So I'll be talking about what is machine learning, need of machine learning terms, machine learning process, types of learning algorithms or the machine learning algorithms, types of problems solved using machine learning. And I'll be talking about one of the aspect of machine learning, that is supervised. I'll just giving a brief about each and every algorithm used in this supervised approach, and then introduction to neural network. It's a part of you can say that AI, and also it helps in natural language processing. That's why I took this also. So this is my first part of the presentation. I'll not be taking too much of things. I'll just briefing about each concepts. And then I'll be talking about introduction to NLP, need of NLP, why it is required to learn about this NLP, or what are its importance, why NLP is difficult, technique used in NLP, components of NLP and applications of NLP, research challenges, and some of the tools and learning resources. And if time permits, I'll take you to a demo. Let me start with the machine learning, the definition of machine learning. You know that machine learning is a branch of artificial intelligence, concerns the construction and study of system that can learn from the data. As you know that you get lots of data from various sources. As you know that each and every components are connected to the internet. So you heard about the Internet of Things. You get the data from the each and every component. You get the data from the Twitter. You get the data from Facebook. You get the data from mail. You get data from every corner. I think, and that too, you get text. You say that 80% of the documents are in form of text. So you get the data also from the text documents also. So as I said, it's a branch of artificial intelligence, and machine learning is used to train your module. So in the next one, the definition of the machine learning also look like this. Machine learning is about predicting the future based on the past. As I said, we get lots of data. So basically what machine learning does is, it's a subunit or a subset of AI. So it is basically used to develop a model to apply the intelligence into that particular module. So what we do basically is, once we get the data from different sources, so we take that data. It may be of text, it may be of image, it may be of speech, it may be of voice. So anything, you take all those data. So if you want to predict something, for example, you want to predict what will be the Sensex, or you can say that if you want to invest yourself, which particular where you can invest. For that, what you need to do is you need to predict what will be the Sensex after 1 month down the line. For that, what we need to do is we take the data and we divide this data into two parts. One is the training data, the other one is the test data. Basically, what we do is, so the whole data will be divided into training and testing. So for that, so we usually take either 60-40 or 70-30. Once we get this 70% of the training data, we take this training data, then we build the model using this training data. I'll talk about how to build this model and which algorithm you're going to use for this in future. I'm just giving a definition. I'm just giving an overview of how the machine learning works. I hope a few of you know that because you have come from the faculty background and also research scholars. But to take up to the next level, I thought let me introduce this. So build a model. Once you build this model, you need to test the model whether it is working fine or not. You know that. So now the COVID problem, everybody says that already vaccination is ready, but it has to be tested. That's why they say that it has to be tested whether the particular vaccination has been tested on human or not, and what are the drawback or what are the side effects of that particular the vaccination which is generated now. So for that, you need to test the data before it gives to the outside world. So that will be tested. If the output is 100%, if I say that you have applied this vaccination for 10 members, and if all 10 get cured without any side effects, you say that this vaccination can be used for human being or unhuman. If assume that you get side effects, or if out of 10, only 5 gets cured, then it means that your vaccination is only 50% accurate. It means that another 50% is not working. So then what you need to do is you need to find a new formula. You need to take a new training data, and then you have to train your module. Then you have to find a new algorithm, train the module on this particular trained data. Then once again, you test it. So then test it. And once you test it, so what you need to do is the testing has been done. If everything is fine, if the accuracy is 100%, then what we do is we'll go into the next level. So that's how this machine learning works. So why it is the need of machine learning, why it is required? It is required because now, as I said, increase in data generation. You know that the data is coming like anything. So you know that you heard about big data also. The data comes from the different corners. So you need to as the data is increasing, you need to analyze the data. So to find the new thing which helped for your business or for your organization. So then you need to analyze the data, increasing the data generation, improving decision making. For example, you know that you want to improve your profit. Most of the time you could have seen that when you go to a shopping mall, you could have seen that if you go this month, the items will be placed in one place. If you go to next month, the items will be placed in a different place. It means that based on the historical data, what they do is they will analyze the data, and then they'll help, that data will help them in taking the decision. Like if I keep this item next to this item, they found that there is an improve in the business. So that's why they'll analyze such data to take the decision. Can I give, you can say that offer on this particular item so that the profit will increases. That is one possibility. And also, as you know, that uncovered pattern and trends in data. What are the trends are available now? So which particular item has been purchased in this particular month? What is the trend of the human or the purchaser, the customer? So that you find out that pattern, and then based on that pattern and trends, you take your decisions. So you to improve your business. That is one example of why you need to have this machine learning and solve complex problems. See, for example, you heard about driverless car. So for that, in order to solve such complex problem, you need to have a machine learning techniques. So next, what are the terms basically we use in machine learning? As I said, algorithms. We use basically the first and foremost thing required is an algorithm. Which algorithm I'm going to apply? Whether I'm going to apply the classification algorithm or a clustering algorithm or the prediction algorithm, which algorithm I'm going to apply. So that is the major thing which is required. So that is based on the data available, you need to decide the algorithm which you're going to use. And the model, as I said earlier, you need to decide what is the model I'm going to develop. Whether I'm going to develop a model for prediction, whether I'm going to develop a model for classification. Based on the available data, you decide which model you're going to develop. And then predictor variable. As I said, that predictor variable is nothing but what you're going to predict using this available data. That's what the predictor variable. So if at all, if I am getting a salary of, so assume that 30K, after 3 years down the line, what is my salary? For that, so then we say that variables are response variable. We use the response variable because based on this response variable, I predict the value. That is one thing about the predictor variable. The response variables are nothing but the features we are going to use, and the predictor variable is nothing but, so you're going to predict what is the feature of that particular based on the available features. So then training data, as I said earlier. So in order to build your module, especially in the supervised learning approach, we use this training data to train the model. For example, if you want to train your model to classify whether it is a cat or a dog, for that, you need to give the input different types of cat, different types of dog. Based on that, you train your model and then use the testing data. Randomly, you choose some cats and some dogs, and then you give that particular to the model. When the model predicts it properly, then you say that, so the model is working fine. So that's what, so these are the terms which usually we use in machine learning algorithm or machine learning techniques: algorithm, model, predictor variable, response variable, training data, testing data. All are the terms which we use in this machine learning techniques. Now, what is the process we follow in building any machine learning model? So basically what you need to do is, first of all, you need to define the objective. What object you are doing it. As I understand that Dr. Raghuveer sir was talking about your research career. Like, first thing what you need to do is you need to identify the objectives. Similarly, for any machine learning model to be developed, what you need to do is first you need to find out the objectives, what you are supposed to do it. Once you decide the objective, then you need to gather the data. So basically what is required in any AI or machine learning approach is data is most important. You gather the data which is required for these objectives. Once you gather this data, then what you need to do is you need to pre-process it. So you need to prepare the data for analysis purpose, because you know that there are some values are missing values, or there may be a values which are entered wrongly. Such things you need to take care. Once you do that pre-processing, then it says that data exploration. Data exploration is nothing but, so you need to, you cannot apply every algorithm for every data which is with you. what you need to do is you need to have a exploratory data analysis. We say that EDA. So what EDA does is you need to analyze the data, and then you need to decide, you need to identify the pattern which is available in this particular data, then apply the algorithm to extract that particular pattern from the given data. Okay, so once you identify the data pattern in that, so based on the algorithm, you build the model. So once you build the model, then you need to evaluate it, as I said. So to do this, you take the test data. Once you build the model using this test data after doing all these process, so then what you need to do is you need to evaluate the model. If the model works perfectly, if the accuracy of the model is around 100%, then you can use that model for prediction. The next step is predictions. So these are the machine learning process followed in any case building a machine learning model or to build a AI model. Okay, I hope I have cleared with this. So then there are types of machine learning algorithms are used, as I said. So one is supervised. So you know that the supervised algorithm works on a labeled example, and then unsupervised, there is no labeled data here in case of this. So basically in case of the supervised, you have a labels. So you will have a set of features and you have a class label also. When it comes to the unsupervised, there is no label is in case of unsupervised. So what it does is basically it is an example for clustering. Basically it works based on the distance measured between each items in a given data set. And then the last one is the next one is reinforcement learning. You know that it's a semi-supervised learning approach. You know that this work based on the reward basis. So if it success, it gets reward. If it failure, it's once again will be trained until it gets the reward of a target value. So as I said, that basically the types of machine learning is divided into supervised, unsupervised, and reinforcement. Example for supervised is classification and regression. And in case of unsupervised, we have a clustering and also we have a dimensionality reduction. Whereas in comes to the reinforcement learning, it will be thrown in an environment. It should learn that environment by doing mistakes and correcting itself. So that is what an example for reinforcement learning. So comparison of all these three algorithms, just to make you understand about these algorithms. So we usually say that supervised learning, unsupervised learning, and reinforcement learning. Now the definition of this supervised learning, as I said, the machine learns by using the labeled data, whereas unsupervised learning, the machine is trained on unlabeled data without any guidance, because there is no guidance in case of unsupervised. So if the name itself is says that supervised, somebody is supervising you. Whereas in case of unsupervised, there is no supervision in case of the unsupervised. When it comes to reinforcement learning, an agent interacts with its environment by producing action and discovers error or reward. Either it may get reward or it may get error. Once it gets error, it should retrain once again. So that is what reinforcement learning is. Now the types of problems which you can solve using this supervised learning are regression and classification. Whereas in case of the unsupervised, it is basically association and clustering. Whereas when it comes to reinforcement learning, it is for reward-based problems can be solved in case of the reinforcement learning. Similarly, types of data. So in case of supervised learning, you know that you must have a labeled data. Whereas in case of unsupervised, it is an unlabeled data. So in case of reinforcement, no predefined kind of data in case of the reinforcement learning. So when it comes to the training, so external supervision is required in case of supervised learning. There is no supervision in case of unsupervised. Once again, in reinforcement, there is no supervision. The approach used in case of supervised is map the label input to the known output, because you know that. So when you're testing, you know that what will be the expected output in case of the supervised. In case of unsupervised, understand pattern and discover the output. So you need to understand the pattern. Say if there are 10 to 15 people are there around your house or the neighbors. So you need to cluster them or you need to classify them to a different pattern. What is the best method? What you can do is either you can do it based on their salary or based on their other parameters. You can just find the similar kind of pattern and you will group it. There is no supervision is involved in case of the unsupervised. So in case of follow trial and error method, so for example, you want to generate a robot. So what you need to do is you will allow the robot to go in a particular path. If it gets an hurdle, then it comes back and it takes an alternative path. So that's how you make the reinforcement learning to happen in case of the reinforcement learning approach. Whereas when it comes to the popular algorithms used in supervised approach are linear regression, logistic regression, support vector machine, and k nearest neighbor. So these are the approaches or the algorithms used in case of supervised. In case of unsupervised, we use k-means and c-means are the most commonly used approaches. Whereas in case of reinforcement learning, it is Q learning, and SARSA are the example for reinforcement learning. Okay, so what are the types of problem you can solve using this machine learning approaches? Basically, we divide the problem, which are the problems, what are the problems comes. We basically divide into three categories. One is the regression, the other one is the classification, the third one is the clustering. So these are the three kinds of problems which you can solve using this machine learning approaches. So coming back to this supervised learning approach, so there are basically into regression and we say that classification. A regression is a problem is when the output variable is real value, such as dollar and weight. It means that it's a continuous value. If it's a continuous value, then we go for a regression approach. So for example, and in case of the classification, so it is a problem is categorical. Like either you say that red or blue or disease or no disease or yes or no. Such kind of approach, you say that classification is used. Coming back to regression, we also have linear regression and non-linear regression. When it comes to linear regression, used to predict the correlation between one or more independent variable and a dependent variable. It means that you will have a one or more independent variable. Say, for example, you want to predict your salary out of after 10 years down the line, then you will take the present salary, then your age, then increment in every year. Those things will be taken and predicted what is your salary 10 years down the line. That is an example for linear regression. And also it says that speeding it is correlated with traffic death. So it is like if the speed increases, there is a possibility of death in the traffic also. That is what example for linear regression. When the data is plotted on a graph, there appears to be a straight line in relationship. It means that it is almost a straight line when it comes to the linear regression. So similarly, when it comes to the classification, as I said, we will have a set of data records, all also called as example instances or cases described by so A1, A2 up to AK. So these are the attributes with respect to each instances. So then a class label, each class example is labeled with a predefined class. See, for example, if you just consider whether the person is going to buy a computer or not, then you will take the age, and then whether the person is you can say that the working or a student. All those attributes are nothing but A1 to AK, and then you say that whether he's going to buy a computer or not, yes or no. It's an example for a class label. Basically, it works on a feature and a class label. So what is the goal? That is to learn a classification model from the data that can be used to predict the class new or a case instances. It means that whether you are going to predict yes or no, whether you are going to say whether the disease is there or not, such kind of problem you will go for a classification. So there are different types of classifications are there. I'm not going to take up in detail, just I'm going to mention about each approaches because most of you know that. So the logistic regression, then you have a decision tree. When it comes to the logistic regression, you also don't get confused with regression. Whereas in case of the regression, you say that it's a continuous value. When it comes to the logistic regression, you say that it's a classification value. You say that yes or no. When it comes to decision tree, so you may have more than one class. For example, whether I can play cricket or not, whether tomorrow is going to be rain or not. All those things can be done using a decision tree because it's a representation of a tree in a reverse order. Each and every node will act like you can say that an attribute which will be helpful in taking the decision. We also say that information gain is also used to split a particular attribute or to choose a particular attribute. Or we also take the value of entropy also in case of a decision tree. And in random forest, so it is nothing but in case of a decision tree, you get one output at the leaf node. So if you have a multiple possibilities of the same data, then you choose, you will vote it. So whichever the maximum vote comes, you will choose that particular solution for your problem. That is what the random forest is about. And Navy-based classifier, it works on so the other three works on a you can say that the statistical approach, whereas in case of the Navy-based, it works on you can say that the probabilities approaches, and then k-nearest, which works on the nearest value. As I said, k-nearest is nothing but the name itself says that you take a k value. If you take k value as 3, what you will do is you will compare this k with the three nearest values, and then you will vote it. Whichever it is the nearest to this particular new instances, then that will be classified to the maximum voting value. That's how the k nearest works. And support vector machine, once again, you will have you can say that a linearly separable line, and then with a maximum of gap between each class. So then you will have a linear separation line. If the separation is maximum, then you classify the upper one is as one class, the lower one is another class. So there is a possibility of non-linear support vector machine. If it is not possible for me to draw a straight line or a line to separate these classes, then there is I go for I say that it's a non-linear support vector machine. So when in case of this, what we do is we'll shift this input into a different you can say that the domain, and then we classify into a different classes. That is what a non-linear support vector machine. So basic these are the approaches of classification as well as regression. So I'll be not talking about unsupervised approach. Unsupervised approach is nothing but, as I said, it's basically works on a distance. So basically you will use the Euclidean distance, marathon distance, all those things you will use. So use those distance value to find the pattern and then group the element into a different clusters. If the values are very close, you place them element into a one group. If the values are between each cluster are different, and then you will place the element into a different cluster. If any items will not fit into any of these clusters, then we call it as an outlier. Okay, so these are the approaches of regression and classification. Now I'll be taking about neural network, as Dr. Mahananda was mentioning yesterday, how important the neural network when it comes to the AI, artificial intelligence. You know that everything works on a base of a neuron. In our body also, a signal will pass through this to our brain, then the signal will pass to the other parts of the organ through this neuron and to the dendrites, all those things. I'll be just talking about the types of neural network concepts are there. I'll be taking into the concept of neural networks, and then I'll move on to the natural language processing. So let us understand the basic terminologies of neural network. So basically we say that neuron, just like a neuron forms the basic element of our brain, a neuron forms the basic structure of a neural network. If you just look at this, so then we have you can say that the nucleus, and then dendrites, which gets the input from the other parts of the body, and then it will pass it to the next neuron or through this axon. Similarly, in case of artificial neural network, we say that it's a neuron which gets its input from various other as features, and then if it reaches a maximum value, then the output will be given to either to the next neuron, or it becomes an output of the neural network. So that's how this neuron works. And continue with that. So you know that we also use weights. When an input enters into the neuron, it is multiplied by weight. And for example, if a neuron has two input, then each input will have an associated weight assigned to it. So then what we do is A1 and A2 are the neurons, and then W1 and W2 are the A1 and A2 are the inputs, and W1 and W2 are the weights multiplied. So why we usually multiply this value is because you need to reach a threshold value. To reach this threshold value, a correction will be done. That correction is nothing but the weight value. And also we have one more term called the bias. In addition to the weights, another linear component is added to the input called as the bias. So basically what we do is we'll add this bias to this value, and then so you'll get an output at this particular neuron that will be given as an output to the next neuron. Okay, so then it says that activation function. So as I said, now this activation function is one which is at every neuron. So it gets the input multiplied by with the weights and the bias. If it reaches a particular threshold value, then that particular value will be passed to the next layer. It means that once the linear component is applied to the input, a non-linear function is applied to it. The activation functions translate the input signal to the output signal. So it means, so whenever you get an input as well as the multiply with the weight plus the bias will be used as a function, and that function, if it reaches a threshold value, that will be given as an output the next layer. So that's what the function is represented. So if you just look at this, all this put together, so you have the neuron where neural network functions. So you will have the weights. So each x1, x2, x3 up to xn are the input. You multiply by the weight, and then you will apply the bias, and then you apply the activation function, which will be given as an output, which gives an output. This output can be given as an input to the next layer, or it may be an output of at the end of the output layer, it becomes an output of this particular neural network. Okay. Basically, we have this different types of neural network. We also call it a feed-forward neural network, where in case of this, each neuron will get an input, and that will be given. It will be given as an input to the next layer, and then it will be multiplied with the weight, bias, as I said earlier, and then it gives an output. It's just a simple feed-forward neural networks. So basically, the feed-forward neural networks used in the applications like simple classification, face recognition, computer vision, and then speech recognition. Most of these neural networks are used in these kinds of application. Only thing is that the output varies from one network to the other network. It all depends upon the computational power you have. Okay, so feed-forward neural network has an advantage: less complex, easy to design and maintain, and fast and speedy because it has got there is no back propagation. It's only a feed-forward. And highly responsive to the noise data. There is a highly responsive to the noise data. The disadvantage is cannot be used in deep neural network because there is no, you can say that the back propagation is not there, and also there is an absence of a dense layer, and also absence of you can say that the intermediate layers. All those things are not available in case of the feed forward. To overcome from that, so we have one more neural network called multi-layer perception. In case of that, you added an hidden layer. So if you just ask me what is this hidden layer is going to do is every input you multiply by the weight, and then you will have a bias, and then you will send it to the next layer. So each layer, there's a possibility of identifying some features or using those values to identify those features or to give an output to the next layer. That's how this hidden layer used. So when you increase the number of hidden layers, automatically it might increase your output, or it may become stagnant at that particular one some time when it reaches the maximum value. That's how my hidden layer works. And also applications are, as I said, speech recognition, machine translations, complex classifications. So those are the applications of this multi-layer perceptrons. And then in case of multi-layer perceptron used in deep learning, because you know that there are possibility of hidden layers, and also it is possibility to get the feedback or the back propagation, where I can get the back propagation, where I'll adjust the value of weight and bias so that my output becomes better. Okay. The disadvantage is comparatively complex to design and maintain, and comparatively slow, because you know that when you increase the number of layers, the computation power is required more. If you need more computation power, then the speed becomes slow. I'll also give you an example of how we can improve this speeding of developing your neural network model using the Colab also. Coming to the convolution neural networks. Now, whatever the neural network which we discussed till now, so what you need to do is, as a developer, you need to specify the input features, what you're supposed to identify. You need to manually identify the features, and then you need to give the features to the neural network as an input. But in case of the convolution neural networks, most of the time we use this convolution neural network for image, and you can say that it will be used for speech and voice type of applications we use for convolution neural network. Now, the beauty of this convolution neural network is, when I give an image, what it does is it will use convert, that is ReLU, it's an activation function. Then we'll use the pool. Once again, it's a function to pool the maximum value. Then you convert this image into a type of features. For example, if I give cat, it identifies different features of cat automatically using the number of layers. So what it happens is, once you find out all the features after going through multiple layers, then you get this particular value, the convert value. What we do is we'll flatten this. When you flatten this, these becomes the features, and then you give these features as an input to this neural networks. Once again, you apply the multi-layer perceptron, and until you get the output, the proper output, what you will do is you will train your model by varying the values of weight and bias. Once you train the module, you will get the output. You keep that output for testing purpose. So similarly, you can just observe that my output may be not only single output, it may be a multiple output. I mean to say that, so if at all, if you are taking an example of character recognition, so I need to recognize the character from 0 to 9. What I do is I'll take the character which is written in 0, handwritten recognition. So once you may write 0 in one fashion, other may write it in another fashion. What we do is we give this input to the convolution neural network, and we till we get convolution. So what we do is when we give this to the convolution neural network, it identifies all the features of this particular character, and that gives us an input to this neural network. Finally, it identifies the weight and bias that will be updated. So similarly for character 1, 2, 3 with different angle, all those things. And then when you give a new input, it will be in a position to classify from 0 to 9 as characters. So might be, as I said, so each output, this output may give 0, this output may give 1, but it will not give more than one output at a time. It can give any one output for a given input. It will not give more than one output for a given input. For example, if I give 9, it should give one of the output, either 9, it should give for 9, it should not give for any other character. If it gives another character, it may be there is something wrong in your, you can say that the configuring your hidden layers and then input layers and all those things. You need to look into it carefully. Now, as I said, the application of this convolution neural network is image processing and then computer vision. You know that you come across Google, you can say that the object detection system, where it has to detect if you just take your mobile app and if you just use that object detection system, it automatically identifies car, and then also it identifies the bicycle, and it also identifies the person who is going on the pedestrian, all those things it identifies. That's an example for this convolution neural network. And also speech recognition, you know that you have a Google Assistant, that is also a kind of example for convolution neural network. And machine translation, you know that in order to translate from one language to the another language, we use this convolution neural network. So the advantage of this convolution neural network is used for deep learning with few parameters, and less parameters to learn as compared to fully connected layer, because you will have because you need not to do anything, because it will be done automatically by the convolution neural network. And the disadvantage is comparatively complex to design and maintain, because it requires lots of computation time. So because of that, it takes more time. So this is about the concept of machine learning. So I'll be talking about natural language processing. So for a 15 to 20 minutes, and then I'll come back to you can say that the challenges which you can use for your research purpose. I hope most of you know that what is natural language processing. It means that, so every time I observe that my own kid, every day when he woke up, immediately he goes to the Google Assistant and he speaks saying that, what is the weather of today in Mysuru? Automatically, the system will give an output. These are the possibilities for a given input. That is an example for natural language processing. So if I ask me, what is natural language processing? It means that a natural language processing is the ability of a computer program to understand human language as it's spoken. So it means that it has to understand. If you speak something, either you speak in English or you speak in Kannada, or if you speak in Telugu, Tamil, and any other languages, if the computer understands as you speak, then there is nothing but a natural language understanding. There are two concepts. One is natural language understanding, and the other one is natural language generation. We'll come back to that. And NLP is a component of artificial intelligence. I hope if you remember yesterday's Dr. Mahananda's speech, he was mentioning that NLP is a component of artificial intelligence. So if you say that, if you say your robot to do something, so then it's an example for an artificial intelligence. It has to understand what you speak. And you know that I was giving an example of, if I speak something, then the system which you have developed, an artificial intelligence system, it has to understand automatically, and it should do for example, you have developed an artificial intelligence system in your home based on how you speak, but still we are not able to achieve that kind of artificial intelligence system. Basically, I hope all of you will agree that you are not able to develop an application which behaves based on the emotion of a particular person. So it doesn't understand the emotion. It doesn't understand. It doesn't give you empathy for a kind of instance if it happens at the particular moment. Because that's why we say that we cannot replace a human with an artificial intelligence system or a artificial human. You cannot do that. That's a challenging for all of us. And the ultimate goal of NLP is to help computer to understand the language as well as we do. So as I said, however we do, because if I speak to you in a different voice, you will easily understand that what is my present situation is, whether I'm happy or whether I'm unhappy. But I'm not able to do that for my computer system. So there is one more challenge for all of us to make the computer to understand our emotional also. That is one more challenge of that. So continue with that. Basically, the NLP is divided into different fields. One is speech recognition. So as I said earlier, the translation of spoken language into a text is one area of NLP. And then natural language understanding. What do you mean by natural language understanding? The computer ability to understand what we say. It has to understand, if I say something, it has to understand however I say. It should not understand in a different way. That is one way of natural language understanding. Natural language generation is nothing but generation of natural language by a computer. So if you speak something, for that, it should give an answer for you. That is what natural language generation. So as I said, natural language is basically into speech and text. So you know that, think about how much text you see each day. So you may find multiple text information every day. Example, you look at the menus. When you go for a, you can say that the hotel, you look at the menus. That is of text. Then you will email, then SMS, then web pages. These things are, and much more are an example for text. So you need to use all these things to draw an intrusion out of it. So that's why it is required. The natural language processing is required to process the text information. Also because we have 80% of the data is available in the form of a text. And also it says that speech is one more area. We may speak to each other as species more than we write. And you know that it may even be easier to learn to speak than write. Voice and text are how we communicate each other. So what I mean to say that why I'm giving these quotes is because these things are easy for human being to understand, but making the system to understand is a challenging task. That's why it is a need of, we need such kind of data to train our system also to behave like human. So how exactly the interaction between human and machine happens? I think most of you knows it, but sometimes we also are very excited to know that when I speak something, how exactly the Google is giving answer for me. Because sometimes the people have also, they also thought about how my machine will work, how it works. Now the answer is a human talks to the machine, and then the machine captures the audio, and then audio to text conversion takes place. So you speak something, it will be converted to text. Then what it does is processing of text data will take place, and then data to audio conversion takes place, because once you speak something, it will convert into text and it will be search for the required information, takes the text, convert that into an audio, and then the machine respond to the human by playing the audio file. So that's how human machine interaction takes place. So coming to the need of NLP, why I need NLP, where I can use this NLP. As I said, language translation, applications such as Google Translation. So that is where we can use NLP. Word processors such as Microsoft Word and Grammarly that employ NLP to check grammatically accuracy of text. That is one area where you can use this NLP or need of NLP. Interactive voice response, IVR application used in call centers to respond certain users' requests. Because so in case of this kind of COVID situation, this kind of applications are very much essential. You train your system to respond to the user request. So that is one area of one requirement of NLP. And continue with that, personal assistance applications such as, you know that most of you heard about OK Google, Siri, Cortana, and Alexa are the example of NLP because you know that your sign might have asked you to play a song whenever you just enter into your home. So that's how an example of Alexa. And by sitting in home, you can just say that to Alexa to play this song. Automatically it plays your song for you. So it's an example of natural language processing. So improved accuracy and efficiency of document, because you know that you have a huge document. So sometimes faculty members will also be, if it automatically works, if I put all the document, it should do in such a fashion that all these documents will be categorized as per the NBA requirement. So it's a challenging for all of us. So it should go and sit in particular, you can say that criteria. So all the faculty who attended FTP, if you just dump all my document, then automatically these documents should go and place in criteria 5 for the faculty attending FTP, published paper, all those things. Such kind of things we can do it using the NLP also. Okay, and then the ability to automatically make readable summary. So if you just throw a document, it should give you a summary rather than going through the newspaper entirely. So what it should do is, based on your interest, based on how you daily look at your newspaper, automatically what it should do is, every day when the newspaper comes, automatically it should summarize you, and you should give an output saying that, so these are the main things which you are looking for, which have come for you to this from this newspaper today. So that's how my automatically make a readable summary, and then allows an organization to use chatbots for customer support. You know that chatbot is a new thing has come up. Now IBM has come up with a chatbot where you can train your model, or you can put knowledge where you automatically responds to the customer request. And then easier to perform sentiment analysis, because it's a more important domain of NLP, that is sentiment analysis. So the system should be easy to analyze the opinion given by the customers. So these are the areas. These are the areas where I need NLP. Because of these requirements, NLP is required. Now my question is, why we feel that NLP is difficult? Most of the time, people will choose different domain rather than choosing this text domain, because sometimes it becomes difficult. Why it is? So because the natural language is extremely rich in form and structure, and very ambiguous. Because you know that in English is we say that it's very confusing, because sometimes I speak in this sentence, so somebody else can give the same sentence in different manner, but the meaning is one and the same, because it's of very ambiguous. So, and it also depends on the context. That's what it says, that how to represent the meaning. Because if I take a cheap, so maybe cheap may be a positive word, or maybe a negative word. It all depends upon the context which you're going to use, and which structure map to which meaning structure. Because as I said earlier, so there is a sentence which is giving the same meaning but of a different structure. One may give in one structure, the other may give in different structure, but both are giving the same meaning. That is one problem with NLP. And one input can mean many different things. That is, ambiguity can be at different level. As I said, the lexical word. At the word level, you may have ambiguity. At the sentence level, you may have ambiguity. And syntactically ambiguity, different way to parse the sentence. Because as I said earlier, I hope most of my faculty members are familiar with parser. You know that in automata, you heard about parser, or in compiler design, you heard about parser. What the parser does is, it parses the given string. It parses the given sentence. Basically, we'll not talk about these things in regular class, but when it comes to an application, you can just mention that how ambiguity works when it comes to the NLP. The same sentence will have a different parse tree. Then we say that the sentence is ambiguous. That is a challenge of NLP. That's why it is difficult. Interpreting the partial information, like how to interpret pronoun. Sometimes this pronoun may be linking to more than one noun also. That is what the interpretation of pronoun is also becomes difficult. And the contextual information, as I said earlier, context of the sentence may affect the meaning of that sentence. Because, so as I said, mobile is cheap. So it may be the mobile is cheap based on the price, based on the quality. So it depends upon the context. Finding the context itself is a difficult task. Interaction among components of the input is not clear. It means that, so if the interaction is not proper, so I speak in Kannada and somebody else speak in English, then the interaction between these two components are not proper. Then once again, it becomes a challenging task. So the technique used in NLP, I'll be talking about the technique. Basically, we use syntactic analysis and semantic analysis are the main techniques used in complete natural language processing. So basically, we divide into two categories, syntactic and semantic. Syntactic with respect to the finding the meaning of the sentence with respect to the structure of the sentence, whereas semantic is based on the contextual information. I'll come back to that. So sentence that is syntactically correct, however, it is not always semantically correct. For example, cow flow supremely is grammatically valid because subject, verb, adverb you have, but it doesn't make any sense. It doesn't give any meaning. That is the difficulty with respect to the NLP. Syntactic is wise correct, but semantically it is not correct. So we'll continue with this syntactic analysis, also referred as syntax analysis or parsing, is the process of analyzing the natural language with rules of formal grammar. I hope most of you know that we use context-free grammar. Why we use this context-free grammar is to parse the string. So you know that you come across various phases of the compiler. You say that the lexic analyzer, syntax analyzer, semantic analyzer, then code generation, all those things. So in order to generate this code, what we are supposed to do is we should make sure that there is no semantically the sentence is correct or the input is correct. To do that, I need to check whether it is syntactically correct or not. To do that, what we do is we pass the string. So that is one step. So then we also say that syntax is the arrangement of words in a sentence to make grammatical sense. So it has to be grammatically, it should be correct. That's why we go for the syntax analysis. NLP uses syntax to assess meaning from language based on the grammatical rules. So based on the grammatical rules, you must be in a position to identify the meaning of the sentence also. That is one way of syntax analysis. Why we do the syntax analysis. And to do this, what we do is we say a lemmatization. We follow some procedure to do this parsing. Before parsing, we do this thing also. Lemmatization. It entitles reducing the various inflected forms of a word into a single form or easy analysis. So for example, geese to goose. It means that it uses a word to come back to the basic meaning of this particular word that is required in natural language processing. I'm sorry. Stemming, it involves cutting the inflected words to the root form. Say you need to, if you say apple, apples, say for example, if you're doing a document categorization, if at all, if I consider apple as one word, apples as one word, apple as one word, then the different word will not give us in doing the document classification properly. So for that, what we do is we'll bring that each and every word into a base level. That's why we go for the stemming. Lemmatization is different. It works based on the meaning of that, whereas my stemming is only to bring it to the base level of the given word, because removing the es, all those things, it works fine. And morphological segment, it involves dividing the word into individual units called morphemes. Like for example, based on the places and the chair, dog, bird, table, all those things are called the morphological things. Word segmentation, it is divided into large piece of continuous text into a distinct. Might be you may ask question, why should I do that? Because if you, for example, if you want to rank your document, how you are going to rank your document? So it is ranking will be done based on the number of a particular word occur in a particular document. So for that, you need to identify which are the noun, which are the verb, which are the adjective. You need to know that. And also similarly, you need to know that if at all, if I consider the a sentence about the feature of a product, or to find the opinion about a feature of a product, I must know which one is a verb, which one is adjective, which one is noun. Before that, I should do what? I should segment the entire sentence into a number of tokens, and then I need to tag each and every words also. Then only I can able to identify that I can connect one word to the another word using my parse tree. So then only I can identify that I can connect the noun to an adjective, so that I can come to know that this adjective, this opinion is about this particular feature. That's why it is required to do all these process like lemmatization, stemming, then tokenization. All those things are required for this particular purpose. So then continue with that. As I said, parts of speech tagging, I must involve in identifying the parts of speech, every word, because I need to divide every word into noun, verb, adverb, adjective, determinant. All those things I need to do to identify the meaning of each and every word also. I need to say that the importance of each and every word. So parsing, it involves undertaking grammatical analysis for the provided sentence. As you know that I define a context-free grammar for a particular statements in a C programming or any programming language. Similarly, we parse each and every English sentence. We'll connect the noun to the verb and then adjective, and we parse the string. Once you parse the string, you will be able to connect a verb to a noun, verb to an adjective, noun to an adjective. All those things can be done using this parsing. So sentence breaking. So you cannot take the entire document into one. What we do is we divide the entire document into a sentence, then into a word, then we parse each and every word, and then we apply the parsing. So that's how these techniques are applied. So word segmentation and the tokenization. For example, the question rises that why should I do that? See, for example, if you consider such languages, these kind of languages, so there is a very much required to determine the word segmentation and the tokenization. Because if you just look at this languages, you are not in a position to identify the sentences. you are not in a position to identify the words also. There is one challenge of this particular natural language processing. It depends upon the language which you're going to use also. So I'm just taking a 1 minute to demonstrate online. If you just give a one particular sentence, how it will be tagged, how we can able to look at each and every tag of the word also. Pushkin, can I go online?
Yes, sir.
Hello? Are
Yes,
you there?
sir.
Yeah.
Yes, sir.
I'll just show this one. So if you just look at this demo, why I'm mentioning this is most of your researchers, you must also know that where I get the tools available for doing this natural language processing. So the basic important thing is you must know Stanford. It provides the parts of speech tagger as well as the parser also. I've used in my research to divide the entire sentence into a number of tokens. And also I've used natural language processing. In natural language processing, I've used the Stanford parser also. Using that parser, I'm able to identify the number of, you can say that the linguistic I've applied, and I've connected one word to another word. Based on that, I'm able to identify the opinion on a particular feature also. See, for example, in this particular example, I'm just giving an example for how the tagging takes place. So this is an example for given sentence. Now it says that based on the color. So for example, this is a verb. It's a noun. It's a noun. So it means that it is able to identify which are all the verbs, which are all the noun in your sentence. So my question is, you may ask the question, why should I do this? So why should I do? Yes.
Sir, we have to share the full screen, sir. Only presentation has been shared now.
Oh, okay. Okay. I'm sorry. Okay. To share it, is it? Is it sharing is happening?
No, sir, not yet.
Okay, I'll come back to this. Is it visible now?
Yes, sir.
Is it visible, Pushkin?
Yes, sir. Yes, sir.
Yeah. My dear participants, I'm sorry. I thought it was visible. Now look at this particular sentence. So what I can do is I can edit this sentence. Say, for example, I say that John met Kumar. So it should divide the sentence into a number of parts of speech, like noun, verb, all those things. If I say past, POS tag, so automatically it tags each and every sentence. Like if you just go through this noun, and then you have a verb, and then you have a noun. Similarly, you can use parts of speech parser also, which parse the entire sentence into a number of verb, adjective, and it will connect also. You can use such kind of things to develop your own applications also. I'll show you a demo where I'm going to use Python NLTK, which is natural language toolkit to use for all these purposes. I'll take that demo also at the end of this, if at all, if time permits. Okay. Pushkin, I'll go to the presentation once again.
Okay, sir.
Is it visible?
Yes, sir.
Hello?
Yes, sir. It's visible, sir.
Okay. Now, coming back to this technique used in NLP. So there are, as I said, semantically analysis. I spoke about syntactic. The next thing is about semantic analysis techniques. So in case of semantic analysis, is the process of understanding the meaning and interpretation of words, signs, and sentences of a sentence structure. So basically, syntax is much easier compared to the semantics, because identifying a meaning of a sentence is a difficult thing. It's a challenging thing. So for example, this lets computer partially understand natural language the way human do. As I said, partially. Why I mentioned this partially? It means that it is not possible to make the system to understand completely because of the ambiguity. So it means that, but this is not been solved yet. It's a challenging for all of you. It has not been solved completely about understanding the meaning of a sentence based on the context also. Continue with this. So basically semantic involves the use and meaning behind the word. So basically we use name entity recognition. And yeah, even Stanford also provides for this. You need to identify the name entity recognition. It involves determining the parts of text that can be identified and categorized into preset groups. For example, groups includes names and names of the people, names of the place. That is required. You may ask why it is required. If it is not, if it doesn't find it, then you cannot relate meaning of one part of the sentence to the another part of the sentence. For example, if I say that the mobile phone I brought is cheaper, so then I should be in a position to identify the cheap is connected to which particular entity. So then I must be in a position to identify my mobile is a name of a particular component. I must be in a position to identify it. Then only I'll be able to relate this with a opinion which is given by the user. That's why it is required. I mean to say that if you say that Mysuru is a wonderful place, so then you must be in a position to identify Mysuru as one place, wonderful as an adjective. So then only you can able to connect this wonderful with Mysuru, even if it is not, if it is possible to identify in the given sentence, the entity is the Mysuru. Okay, that is one requirement of natural language processing when it comes to the semantic. And also co-reference resolution. Now, anybody can tell me, it says that determining which phrases in the document refer to the same underlying entity. Now, I'll just take an example. Anybody can tell me what is the problem with this particular sentence? It says that John put the carrot on the plate and ate it. What is the problem with this sentence? Pushkin, you can take up to the audience.
Okay, sir.
Anybody, if you have any answer for this, what is the problem with this particular sentence? Anybody can answer for this. What is the problem with this? How will you relate the carrot and plate and hit? How you are going to relate it? Any answer from the audience? Pushkin? Anybody are there responding?
Yes, sir. We are waiting, sir.
Sorry?
Waiting, sir. Waiting for the answers. They have to
Okay.
type in the chat
Okay.
box.
I'm just waiting for your answer because we want this to be interactive. I'll take up the next sentence also if you answer to this question. Okay, John as subject. Good. Then how will you relate? Grammatical error. Okay. How will you relate? Or I mean to say that the question might be like this: whether it is related to the carrot or to the plate. How will you relate it? How will you resolve this it? Whether you resolve this it to the carrot or to the plate. Subject, verb, object. Okay. Very good. People are responding. My question is whether the it, plate as noun. Very good. Now my question is my verb, adverb, that is it, is connected to what? It's not on the plate. Okay, very good. Now the problem with this type of sentence is, I don't know whether I need to relate this it to the plate or to the carrot. Now, if you say plate, it is related to the carrot. Very good. It is related to the carrot. Now, you as a human being will be in a position to make this it to correlate to the carrot. But as a machine, it will not be in a position to understand whether I am supposed to correlate this it to the plate or to the carrot. That is an example for, you can say that example for co-resolution, co-reference resolution. And once again, the example is Bush started the war in Iraq, but the president needed the consent of Congress. Now the question is, who is president here? Whether the president Bush is president or which president is in this particular sentence. That is one more challenge of correlation references. Okay, so that is the challenge of this semantic analysis. Moving to this word sense disambiguation, it involves giving the meaning to a word based on the context. You know that, as I said earlier, if I take cheap may be you can say that it may be a positive word, or it may be a negative word. And the last thing is natural language generation. It involves using the database to derive semantic intentions and convert them into a human language. That is the natural language generations. For example is speech recognition. For example, has got very good and works almost flawless, but we still lack this kind of proficiency in natural language understanding, because speech recognition might be works fine, but it doesn't work in every time, because there is a kind of proficiency is required in understanding the language also. So your phone basically understands what you have said, but often can't do anything with it because it doesn't understand the meaning behind it. Sometimes it doesn't understand the meaning behind what you spoken. So there is one challenge of natural language processing. Okay, so as I said, basically that divided into components of natural language into two things: the natural language understanding. In case of natural understanding, we follow different level of analysis is required. As I said, morphological analysis, syntactic analysis, semantic analysis, and discourse analysis are the nothing but the natural language understanding. Please understand, this is the steps which are used in case of the natural language understanding. Whereas in case of natural language generation, producing the output in the natural language from some internal representation. So it's a reverse of it. Different level of synthesis is required. Deep planning, what to say, syntactic generation. Then you need to natural language understanding is a much harder than natural language generation. I mean to say that two are the components. One is the natural language understanding. The other one is the natural language generation. Out of this, natural language understanding is much harder than natural language generation, but still both of them are very hard to do it. Okay, so I already mentioned about the applications of these NLP. One is AI application. You know that virtual assistants. I already spoke about that. If you just ask the weather, what will be the weather of this prediction of, you can say that when you say what will be the weather, just ask, it will give you the weather of 1 week also. That is one example of NLP, a question answering system. You know that if you just throw a question, it will give you an answer for you. That is one example. Automated customer service, because you know that most of the banking sectors are now changing from human, to the manual to the automated this system. Like you know that we have initiated you can say that center of excellence called the RPA, robotic process automation. Most of the banking sectors are coming up with their own bot to handle the user request. So when you speak something based on the word which you have used in that particular the system will respond to you. That is one example of natural language processing. And tutoring system, where the machine interacts with a student. For example, an automated mathematic tutoring system. So that is one example of natural language processing. Spoken language of a machine, that is voice control, as I said earlier. Production level applications. So a computer program in Canada accepts daily weather data and automatically generates weather report in English and French. That is a production level application. So you can have a product level application also. A visitor to Cambridge. So when you visit a particular place, even if you doesn't know the language, if you spoken in one language, it automatically gives an answer to the question raised by the visitor. That is one example of production level. And the prototype level. Please observe the prototype level. Computer grade student essay in manner indistinguishable from the human graders. Say, for example, if a student has written an essay, so if you give this essay to a human as well as to the computer, so you must develop a system which is indistinguishable from the human grader. So if a human has graded and a computer has graded, it should be almost same. I hope all of you know that there is already a system is available from the IBM to play a chess, and a grandmaster has also lost chess against a robot also, or the AI system also. An automated reading tutor intervenes through the speech when the reader makes a mistake. So if I'm speaking, if I make a mistake, automatically my AI system should say that you have made a mistake, please correct it. So that is one application we can develop. That is a prototype. So you can say that a computer watches a video clip of a saucer game and produces a report about what it has seen. So it should report. So for example, if you watch a movie, then automatically it should report saying that what is the outcome of this particular movie also. If you watch a webinar, automatically you should keep a system in place of you. If you keep a system, the system should look at the presentation of the webinar. It should give a summary of that. So that is one example of a prototype application. And then computer predicts upcoming words and expands abbreviation to help people with disability community. So you can help the disability community also using this natural language processing. Coming back to research challenges. So give me 1 minute time. Hello. Yes, coming back to this research challenge, I'm sorry for that. Research challenges, semantic analysis can still be a challenging. As I said, there are some challenges. Please, my dear students and research scholars, you can note down a few of these challenges. Even though you say that these are the existing, but these are the still existing challenges also. Word sense disambiguity still be a challenging task, because as I said, still you are not in a position to segregate the particular word based on a context also. You can work out on that. Cross-domain sentiment analysis. For example, you have developed a system for one kind of application, and if you question for a different kind of thing, then your system will not be in a position to answer it. For example, in an Amazon, if you ask for one product and if you question for another product, then it will not be in a position to answer also. Such kind of things you can develop. Cross-domain sentiment analysis, you can do it. And sentiment analysis in regional languages. See, most of the time what we do is we'll do for English, but we never thought about doing a sentiment analysis for a regional language, but people have worked on that also. So what they did is they have taken the Kannada and then they have translated it into English, and then they match that English opinion to the Kannada. Rather than that, I suggest you to develop an application which is used for a regional language. I'm not saying that Kannada, for your own regional language, you can develop the system also. If it exists, you can make it better. Construction of Kannada parser, I was told my students to look into that, because people have worked on that. There is a shallow parser, but still there is a scope for developing a Kannada parser to parse the given sentence so that you can find the meaning out of the sentence also. But compared to English, Kannada is a toughest language. And sentiment analysis for a product from public sectors like agriculture product, milk product, because when I was doing my research, people have suggested me, see, you do for a particular company. For example, I took the reviews of Amazon and Flipkarts and other leading companies, and I do the analysis, but already those things have been available in their particular website. Instead of that, so try to develop an application where you will do it for an agriculture product. You must say that for a particular agri farmer. So if you use this particular pesticides, or if you use this particular fertilizer, your yield will get improved. Or take the feedback from the farmer after using the fertilizers. How is the yield of a particular crop? So you collect all those things and then work on that, and then give a feedback to the farmer also. Give a suggestion or give a recommendation. Those things are not been done by any of us, so you can look into it. And the milk product, so you can take the feedback from the customers and then improve the product of the milk also. So similarly, you have any public sector product, you can use those products for the analyzing the sentiment also. Continue with that, extraction of meaning from variety of complex and multi-format document, because you know that the documents come from different types. One document is of will have a fully of image, the other document is of text. So what you need to do is sometimes you need to correlate. Sometimes you could have observed that in one newspaper it is in the text format, other newspaper it is in a you can say that image. You must be connect these two. So if you say that George Bush has spoken about this, so then you need to collect, if at all, if you just have an image and if you have a text in another document, you need to connect these two to come up with a proper conclusion. That's how we can do it. And sometimes it also so happen that you have a document which is in PDF, document is in Word, then sometimes it becomes difficult to extract the meaning. I mean to say that to extract the sentence from the such kind of document, you can extract and connect these things also, becomes a multi-format documents also. I recommend a system for farmer. As I said earlier, you can recommend the farmer to choose a particular fertilizer, or you can based on their area, or you can say that the available facilities, or the how the people are consuming the product which has been developed by the farmer. Based on all those things, you can collect the feedback, or you can look into the APMC feedback, and then based on that you can recommend for the farmer also. If you just build this particular crop, you may get a better price for this particular year. You can give such recommendations also. So English to sign language and vice versa. See, most of the time what we do is we do sign language to the text. So sometimes it so happen that, see, I find a person who is not able to speak. So then if I want to express something, I'll not be in a position to express this because I don't know sign language and he doesn't know English. So then what you need to do is you must have a system. If I speak in English, automatically it should generate me the sign language. So you could have seen that in TV channel, in you can say that the national TV, if a person is speaking and the other person is speaking, is showing that in a sign. So I want that to happen automatically. You can work on that also. Kannada to text sign language, because this is for our own regional people. If you can able to convert this Kannada to sign language also, in one domain you can look into also. So dialect prediction from speech, because so you need to find out in what accent the person is speaking, whether it is person from a North Karnataka or a South Karnataka, South India. All those things can do it using this speech conversion. And preventing endangered languages means endangered language. I mean to say that the languages are already vanishing. So you can create a data set. So please remember, my dear friends, creating a data set is also a challenge. If you create your own data set that will be used for a further research, is also one of the research challenge also, a research problem also. You generate a data set which the languages are already vanishing, so that you can keep that language for at least to show in future that these were the languages that were there in our country. That is one thing. And legal document classification and summarization. So coming back to this particular challenge, see, most of the time we do classification and clustering for the different document, because I myself worked on this particular work, and now still today I'm getting lots of citation for that particular paper, which I worked on a topic model. Using the topic model, I've classified the document into different categories, and I have also generated a summarization, but still you can improve it further. The question is why I'm supposed to do this, because you know that there are many cases where are there in you can say that at the district level court, and then taluk level court, and the high court, supreme court, all those court, there are number of cases are there. So you know that you cannot declare the judgment for a case in a stipulated time. It takes years to get. So if you just develop an application where you can generate a summary, and also I have one more request, legal document summarization for regional language also, one more. So what is the meaning of this is, if you're able to generate a summary, if there is a case comes, then look into the judgment happened to this particular similar kind of case, and you can give an input to the judge saying that these are the similar kind of cases. For that, the judgment has happened. This is the judgment has happened. So that automatically it gives an input to the judge to taking the decision. I mean to say that you can solve this judgment very fast. So I understand that in US, they have developed an application. If I just give a case, it gives a judgment automatically based on the history and the similar kind of judgments also. So, and also people have worked on legal document clustering in the classification, foreign languages, foreign country people have worked, and I don't think so people from India have worked on that. I have worked on that, and also for Kannada language, people can work on that also. Crime detection through voice and language. I understand that there was a problem statement, there was a work has been carried out. So people, what they do is they do mischievous thing or the criminal thing. At that time, they use different language, and then after the criminal, they use a different language. So what you need to do is you need to develop a system. So based on their voice, you should be in a position to identify whether this particular person has made a criminal or not. So voice to language, you need to identify it also. And labeling of data is again a challenge for supervised machine learning tasks. So because you know that tagging the document is once again a challenging thing. So you need to tag the data. Once you tag the data, so that can be used for supervised learning approach also, because identifying the proper features and labeling a document is a challenging task for once again. A machine can fail to comprehend the context of text unless properly and carefully trained. I mean to say that one area you can look into is context identification. So on which context this particular sentence is about. So that context, words and disambiguation should happen using this context also. So electronic medical record, still there is a scope for this analysis of electronic medical records. You can do that also. Low resource languages, there are plenty of languages are available. For example, in India itself, there are around 22 languages are available. So for that, so there is a scope for converting from one language to the another language also. So coming back to these tools, I think we can use Stanford name entity recognizer. I can use Stanford parts of speech tagger also, Stanford parser also. Then I can use NLTK Python for lemmatization, stemming, and removing stopword. I'll show that also. And GenSim is a Python library for topic modeling and document indexing. And then Intel also has got NLP architecture, which is written in Python for deep learning topologies and techniques. So there are a few learning resources for to help you. You must know how to learn NLP. So for that, have a background of knowledge about probabilistic and statistics, and then basic maths like linear algebra and calculus, and then machine learning approaches, programming. Basically now it is in boom is Python programming, and then you can read the textbooks. There are few textbooks also there, and there are few practice with programming exercise. You can do 100 NLP drill exercises also there, and then programming tutorials also available. Basically you can find out a data set from a Kaggle, so where you get lots of data set to work on this natural language processing. I think Pushkin, I think I've taken almost you can say 1 hour 20 minutes. Shall I go to the demo? If people are ready to see the demo, we can go to the demo also.
Yes, sir. You can share the screen.
Yeah, I'll just take one example where I'm going to show you about how we are going to do this tokenization, lemmatization, and then you can say that sentenced into number of breaks, all those things I'll show you. You can just look into it. One second. One second. Okay. Able to see, Pushkin?
Yes, sir.
Hello?
Yes, sir. It's visible.
Yeah. Code is visible, is it? Yeah.
Yes, sir.
My dear research scholars or whoever is there and participants, see, there is a collab given by Google. What this collab does is, because most of the time, what we do is we use this machine learning when it comes to the machine learning and natural language processing, or you can say that the image processing and then speech recognition. We need to have, you can say that GPU. That is, you need to train your module for a huge data, and you need to have GPU for executing your or to train your module and all those things. What the Google Colab does is it provides you a Google Colab where you can connect to a Google Colab, which provides, you can just observe that there is a RAM and there is a disk, which gives you a continuous GPU support of, I understand that around 12 GB of GPU, which will be provided. It's a continuous facility available with a break of 2 to 3 seconds breakage in between this 24 hours. So what I mean to say that you can train your module using this Colab. The advantage of using this Colab is whatever the program you do, it will be saved on your own drive, Google Drive. So once you develop this application, so it is very easy to use this application wherever you want to use using a simple internet facility. So all those things will be available in your Google Colab. Just for your information, I hope able to see the drive. Are you able to see the drive?
Yes, sir.
Pushkin, is it drive is available? Drive is able to see the drive? No?
So the RAM and disk will be showing, sir. Yes, sir.
Okay. I'm supposed to stop that, and I'll show you at the end the Google Drive where you can find the Colab also. Now coming back to this program, you can just observe that I'll just executing this statement by statement. Now first of all, I need to import or download all my stop words, wordnet, and tagger, all those things. It automatically download. So this will be automatically downloaded. So you can just observe that import NLTK, that is Natural Language Toolkit in Python. It is available for free. You can use it. So I'll execute this. It will automatically download all these things. You can just observe that Punkit, that is nothing but tokenization, sentence tokenization, all those things. Word tokenization will be done by this particular package, and also stop words, and it also connected to the wordnet. It also gives the perception of taggers. Taggers, all those things will be done automatically. So once it is done, so then we'll go on to the next step, that is you can just see that tokenization, sentence tokenization. Now the sentence given is hello Mr. Smith. So this is what the sentence which is given. So we need to divide this into a proper sentences. So for that we use this tokenize import sentence tokenizer. Once I use the sentence tokenizer, it divides this into sentence tokens or sentences into a number of sentences. So you can just see that it is divided into number of sentences. So it does tokenization of the sentences. So please understand it is dividing into number of sentences. And then you also use that, divide the given document into sentence first. Then you divide that sentence into tokens. That is nothing but words. So you can just execute this. You can see that those things have been divided into number of words. Earlier it was sentence. Now it is divided into words. So once I do that, what I do is I'll check the frequency also, like how many samples have been generated. So 25 samples out of and 30 outcomes. So you have a 30 outcome for the given input also. Then you need to say that find out the most common word occur repeatedly, which is now minimum 2. So if you just see that is and comma are occurred, minimum number of times occurred is 2. So frequently occurred words are is and comma. Okay. So then I have a matplotlib which plots the word occur in the particular given document, how frequently the word has occurred. So it is giving in the terms of the graph also. Then the next thing is I need to remove the stop words. You know that. So in a given document, the stop words like is, at, the, all those things doesn't give any meaning. So we need to remove such stop words also. To remove that stop words also, we have a Python stop words. You can import the stop words. As I already said, I have imported the stop words list. So using that, so from the given corpus, so I'm going to remove the stop words also. Once I remove the stop words, you can just see that after removing the stop words, print stop words. So these are the stop words which is identified by the system, like these, and, yourself, up, were, having, wasn't, or not are the stop words which have been identified by the system automatically. Okay. So once I do that, then I'm going to do the tokenization also. Like I'm going to identify the tokens of each and every word of a given sentence. I divide it into tokens also. You can just see that it has been divided into tokens. So once I get this token, I do the stemming. So stemming is nothing but what? I'm going to bring that into you can say that the basic level. So filter sentences, then I can say that stemmed sentences. So you can, wherever you have continuing, then you can say that city has been removed to city. So then I am applied the stemming also. Then I'm going to do the lexicon, which is nothing but lemmatization. I'm going to apply the lemmatization also. So once I do the lemmatization, so it means that, so the lemmatization, what the lemmatization will do. So if at all, if I have a fly, it will go to the base meaning of that. So please remember that the stemming and lemmatizations are different. Stemming will remove only the yes, all those things. Plural will be bringing to the singular one. Whereas my lemmatization will go with respect to the meaning using the wordnet also. So once I do that, so the next thing is parts of speech tagger. I can tag each and every word also, like Hulberts, all those things are nothing but it is divided into number of tokens. So then I given that into the parts of speech tagger also. Then once I do that, I do the tagging also. You can just observe that Albert is noun, instant is noun, was is verb, and then born is verb now. All those things will be done automatically. So these are the basic things which are required for a NLP. Later you can have these things for generating the, you can say that the parser. Then once you generate the parser, you connect each and every word, and then you can identify the meaningful from the given sentences. So that's all from my side. Over to Pushkin. If you have any questions, I'll be answering to that question. Pushkin, should I stop screening or it's still sentence? Okay, fine. Okay. Any questions from the audience? Now, my sincere request is there is lots of scope for natural language processing, as I mentioned, especially towards taking the document, finding the summarization, and then finding the meaning or the semantic meaning, and then opinion mining. All those things are the huge area where you can look into it also. Okay. Pushkin?
Yeah. Yes, sir. So waiting for the question, sir.
Okay, fine. I hope the sessions was fruitful. If no questions, we'll end this session. I thank management, principal, and the organizer for giving an opportunity to share my knowledge, whatever I have learned, and I thanks for giving an opportunity to share my experience. I hope my session has given some input to the research scholars where they can look into these problems and they can start working on that. So if there is no question, I thank once again all the participants for patience listening, and looking forward for your kind support in future also. Thank you, Dr. Parmesh and his team, and thank you.